All right, so let's start off. Let's write down the distance formula. So who remembers from yesterday or from past years? If I've got, whoops. What is the distance between points, we'll call it x1, y1, and x2, y2. Now keep in mind here that the ones and the twos up there are not superscripts. They're not exponents. What do they mean? Yeah, which point we're talking about. Is it the first point or the second point? Right? So we put ones next to the x's and the y's in each ordered pair, just to keep it straight. But what those stand for are numbers. Those stand for the number coordinates that go with those 2 points, right? So based on those 2 points up there, somebody tell me then, what's our distance formula? What's the distance formula? If these are the 2 points that we're considering. Good. Square root of. Okay, forgot something important there. Square. There you go. Good. Okay, very good. Okay, and so that's all we've got to do then is we've just got to plug the numbers into that formula and simplify that. There are some tricks that I'll show you today when we go through these examples that make this process a little bit easier. So let's try this one. Let's plug the stuff in that we know and see what we get. So in this case, it doesn't matter which one you call x1, y1, and which one you call x2, y2. Either one of these 2 points could be the first, and either one could be the second. Doesn't matter. You just have to be consistent once you've picked those points. Okay? So what does our distance formula look like then if I plug in this information? Okay, everybody see that? So we're going to say this x value, 6, minus that x value, -5, right? And when we do 6, when I subtract a negative, what happens? And here's how you can remember that. If I'm subtracting a negative, instead of writing minus negative, I'll write it this way. This seems really silly and insignificant, but it helps. Make it minus negative, it turns into a plus sign. Okay? So 6 minus -5 is 6 plus 5 squared plus -2 minus 4 squared. Good. Okay? And if I keep going with that, what is 6 plus 5? 11. And what is -2 minus 4? Okay, -6. But I got a question for you. If I square a negative, like if I square, for example, -6, what's my answer going to be?
Positive.
Positive. Okay, so here's a rule that you can always follow in math. It will always help you. This will help you avoid, hundreds of mistakes throughout your math careers from here forward. Whenever you're squaring a negative, instead, square the positive opposite, always. And the reason you do that is because the answers are going to be the same. And you avoid making mistakes that are very easy to make. For example, if you don't put the negative sign in parentheses in a calculator, it's going to give you the wrong answer, and that's so easy to do. So always, whenever you're squaring a negative, just square the positive opposite, okay?
Yeah.
Let me, real quick, if you have any headphones or anything like that, please put all that stuff away. Just a reminder. So we're going to make this, instead of a -6, we'll just make it a +6 squared. That helps. It really does help. Makes things easier. So what is 11 squared? What is 6 squared? So I get the square root of, what, 157? Now in this problem, it says just round your answer to 2 decimal places. So all I've got to do is just put that in a calculator and make it a decimal. Okay? So, and somebody, did we have a calculator out? Nope, here, I've got one. Yeah, what's that going to be? It's going to be a little, yeah, it'd be 12 point something, wouldn't it? About 12.7 something, I'm thinking. We'll see. 12.81. Let's see. Okay, so we'll do square root of 157 gives us 12. Oh, I was way off. 12.53.
Dude, I'm so close. You said 12.57.
That's pretty good. And that's what we did. Okay, we just rounded 2 places. Okay. Oops, 5.53 should have been. No, oops. Okay. Try another one. Okay, it's a little different problem.
Yeah, I don't get these ones.
Okay, this is, it's asking us to do the same thing, except it wants a different kind of answer this time. It wants, instead of rounding to 2 decimals, it wants us to provide an exact answer. Okay, a simplified exact answer. Now let's talk about that for a second, because that's important. Was the last answer exact? No, it was rounded, right? It was not exact. We changed the answer, we rounded it to 2 decimal places. An exact answer cannot be rounded. An exact answer either has to be a decimal that terminates, that stops, or it has to be written in a different way. Okay? In this case, we're just going to leave it as a square root of something. Because if I say, just as for example, if I say something like, let's compare these numbers. The square root of 2 and 1.414. Okay, this is roughly equal to the square root of 2, but it's not exact, right? Because I've rounded. This is, however, exactly equal to the square root of 2. That's what it means. As a decimal, that would go on forever. It would never terminate, never repeat. It would just keep on randomly changing forever if I wrote it as a decimal. So I could never write it as a decimal and have it be exact. But that symbol means the square root of 2. Somebody tell me, what is pi exactly?
Like a
What's 3.14159, blah, blah. Oh my gosh, look at that. Okay, so it goes for a while, but you could do that your whole life and never give me the right answer. If somebody could give it to me real quickly right now, what is pi exactly equal to? Pi. That's the right answer. Pi is exactly equal to pi. And so if I want to write down pi as an exact number, I write it like that, and that means pi. Exactly. That stands for all infinite decimal places of accuracy. Okay? What is pi, by the way? It's a number. How do we define it? Well, it goes. Yeah, it's irrational, so it goes on forever as a decimal. But if somebody really asks you what pi is, it means that number. But what is it? It's kind of interesting what it is. You don't really oftentimes think of it this way. We'll come back to this later in the year also. But can anybody remember from previous years, what's the definition of the circumference of a circle? The circumference of a circle, which is the distance around a circle, right? Perimeter of a circle, equals what? 2.
Oh, really?
Yeah.
Oh, yes.
2. Do you remember? And we'll cover this year. 2 pi r. It's 2 pi r. 2 times pi times the radius. And what is 2 times the radius for a circle? What do we call twice the radius? The diameter. Good. Okay. So and we'll do this again. I could also write this as pi times the diameter. Then, if I just glob the 2r together and make it a d, right? So if I solve for pi there, if I divide both sides by d, would you agree that pi is equal to c over d? That's a really important answer. Because did I specify how big the circle was?
No.
No. I didn't, did I? It could be for any circle. Pi is always equal to the ratio of the circumference of the circle to its diameter. Circumference divided by diameter is what is pi. That's what the number means. Okay? That's pretty cool. So it's a universal constant. Anytime you have any circle in a flat geometry, that's how we define pi. Yep.
So like you could check the answer while you're doing the whatever and if it comes up in pi, then you're right?
Well, I mean, the answer, once again, if we get down to how do we express that number, it's kind of it's impossible to write it as a decimal, so we just give it that symbol. But that's what that symbol means. It means the ratio of the circumference to the diameter of any circle on a flat plane. Okay. Yes, ma'am.
So, like, there really isn't, and you don't know how much there is, because
No, people have looked at pi, not people, computers have looked at pi out to, billions and billions of decimal places, and there is, in fact, it is as expected. There's no pattern, never stops. And it just goes forever. Okay, so back to business here then. Okay, so what about this? If we want to find an exact answer, we're going to do the same kind of stuff we did before, only the last step is going to be different. Instead of just putting it in our calculator, we've got to write this in exact form. So distance formula, remind me again. Distance equals square root of, okay, and instead of saying parentheses, the way we say this in math, we say the quantity means in parentheses. Good, x2 minus x1 squared. The quantity, very good. Good. Okay, so we'll just plug in the numbers and see what happens, right? So what's this first quantity going to be, the x2 minus x1?
negative 13 minus
Okay, so negative 13 minus negatives plus 15 squared plus somebody else. What's the next part going to be? Good, 5 minus negative, so plus 3 squared. Okay, let's kind of we'll hurry this up just a little bit. We'll combine a couple steps. What is negative 13 plus 15? 2 squared, 4. 3 plus 5 squared, 64. Okay, so then our answer is the square root of 68. Is that exact? Yeah, that is exact. That is the exactly correct answer, but for full credit, that'll get you 9 out of 10 on the homework or the test. But to get 10 out of 10, we got to simplify that. We have to go one step further. Now our goal when we're simplifying radicals like this, and we'll get a lot of practice on that next year especially, but a little bit this year too, we want to get as much of the number outside the radical as possible. And so the way we do that is we always ask ourselves, is there a perfect square that divides into 68? And somebody remind us here, when I say perfect square, what's an example of a perfect square? Okay, so 4. 2 squared is 4. There's one perfect square. 3 squared is 9. 16. 5 squared is 25. 6 squared is 36, etc. Right? We just keep on going. So do any of those divide into 68 evenly? Well, the next one would be 64, and so that's not going to divide into 68, is it?
No.
36 won't, 25 won't, 16 won't, 9 won't. 4 will though, won't it? Okay, so we could rewrite this as, I could split up this 68 into a square root of 4 times a square root of what? 4 times what is 68? Well, what's half of 68? Half of that? 17. There you go. Okay, right? Does that make sense? So we've broken up the 68 into a 4 times 17 because what's the square root of 4? So that's our exactly, I mean, that's an exact answer that's also simplified. Okay? So that's what we really want to put there. Okay? How do we enter that in Moodle? Okay, so in Moodle we would say 2, well you could put a times there if you wanted, times square root of quantity 17, yeah, and that's going to do it for us. Okay, that's how we say 2 times square root of 17. Make sense? Okay, now there's 3 questions at the end. that are really good questions. These, I'm pretty proud of these. They are gonna make you think a little bit. They're gonna have you use the distance formula, but they're pretty challenging. I'm gonna help you get started on one of those, but then I want you to really, I'm gonna let you work on the rest of them. Right there, there's one of them, okay? So they tell us point A has coordinates 5, -8, point C has coordinates 4, -2. They're telling us, what does this mean right here, by the way, if I say BC with nothing over the top? Yeah, what does that mean? Now let's look at the different ways. If I write this, what's that mean? Okay, that means line BC. What if I say this?
That's the line segment.
That's the line segment BC. What if I just do the BC by itself?
We don't know.
There's two ways to interpret that. I could think of it as the measure of the line segment, meaning the length of the line segment, BC, which we could also say as what? If it's the length of the line segment connecting B and C, it's another way of saying that. Distance. Distance between B and C. Okay. So that's a way that we can write distance. Now it's telling us the distance between points B and C is 6, and it's telling us that angle ABC is a 90-degree angle. Okay? So this, and we're supposed to find AB. They give us a little hint here. They tell us that segment BC and segment AB need not be horizontal or vertical. Okay, so they might be at angles. This is a prime candidate of where a sketch is probably going to be very helpful. So let's do that. Let's draw ourselves a picture. And graph paper would be really nice. I don't have graph paper right here, but we'll make do. So A is at 5, -8. So I'm going to go over 5 and down 8, right? So there's point A with coordinates 5, -8. What about point C? It has coordinates 4, -4, +2. So that means I'm going to go, where do I go first to get to C? Okay, 4 in which direction? Left. And then what about the 2? Up 2. Okay. So right about there-ish. Okay, now it also tells us that point B is someplace on here, but angle ABC is a 90-degree angle, right? So then there's really only two ways I could draw this, right? If B is going to be the right angle, either it's going to have to be up here somewhere, or it's going to have to be down there somewhere, right? Everybody agree?
Yeah.
So I could do this. I could make it go out kind of like this and call that point B. Or I could draw it down this way. I didn't draw that very well. I could draw it down here somewhere. So it goes like that and make that point B. It'd be one or the other. Now, we don't know what the coordinates of B are. But what it does tell us is that the distance between B and C is 6. Okay?
So we would have to be the top.
Yeah. Why is that? Okay, so if I know that this distance is 6, any suggestions here what I can do? I think you guys think about this a little bit. I'm going to get you started on this one. I really want you thinking about this. If that's 6. Now, what about this? I'll give you a good hint. What if let's just assume it's the top one for now. That's a right triangle, correct? Okay, what do you know about right triangles? 90 degrees. There's a trick. How are the sides of a right triangle related? No. And we're going to do more of this year, but I know you've done this before. If I take any right triangle, quick review. Everybody knows this. If the hypotenuse is C and the legs are A and B, Pythagorean theorem, right? Remember that stuff? So we know A squared plus B squared equals C squared, right? Agreed? Okay, so if I go back over here then, if I know that this is 6, and I don't know what AC is, but I could find it, couldn't I? Right? I'm trying to find out what AB is. So let's call that's our unknown. Let's call that X, right? if I knew what this distance down here was, and I could find it, then couldn't I use the Pythagorean theorem to solve for x? Right? Because I would know that x squared plus 6 squared must equal whatever our distance is. Right? We don't know yet, but that's where we can use the distance formula. Whatever the distance squared is.
Wait.
Yep.
How did you get 6?
Because it tells us that.
Oh.
It tells us that the distance from B to C is 6. Right? Okay, so now let's maybe do one of these. Let's how about if we do this one as a group, and then I'll let you guys do the rest of these on your own. Let's figure out what this distance is, and that'll be helpful to us. So what numbers go into the distance formula here? What minus what to start? Okay, so we could do -4 minus 5 squared. Now somebody else help me with the other part. What's the second one gonna be? I think I heard it 2 minus negative, so 2 plus 8 squared. Okay, what's -4 minus 5? -9 squared. No, 81. Okay, so this equals square root of 81 plus, what about 2 plus 8? Okay, good, that's 10 squared is 100. Everybody with me?
Yeah.
Okay, so it equals the square root of 81 plus 100 is just 181, right? Okay, so in our little triangle down here, maybe we ought to redraw this. In our little triangle we've got, this is point C, this is point A, and this is point B. We said that was 6. That's the square root of 181, and this is x, right? So what does the Pythagorean theorem tell us then? What squared plus what squared equals what squared?
6 squared plus x squared.
Ah, good.
equals
Okay,
180.
good. The hypotenuse is always the side, the big side, that's opposite the right angle. So that's the one that's by itself, right? Okay, so we end up with the equation then. 6 squared plus x squared equals the square root of 181 squared.
What did that cancel?
Ah, good, good.
So
So let's talk about that. Let me grab this and we'll go to a new page. I'm running out of room. Yeah, fancy. Okay, so yeah, what happens if I square a square root?
it would cancel.
They undo each other, don't they? Right? Because they're opposite processes. Okay, we'll say they're inverses later. They cancel each other out. So whoops. Oh. So that cancels with that, and I just get a 181. Right? And so what's 6 squared?
36.
36 plus x squared equals 181. What could I do now to
Subtract 36.
subtract 36? Those cancel. So I get x squared equals 181 minus 36, which is what, 145?
And square.
Square root it, we got it. How about that?
That's awesome.
Yeah.
Now
And it wants your answer just as a decimal, so I'll just put it in my calculator. See how that works? Okay, that's a good problem. Tricky one. Okay, I'm gonna let you do a little work. So